Have you ever wanted to create your own galaxy? Not just an image, but a living spiral mass of stars generated procedurally? Today I'll show you how to do just that in GoDot, step by step. Hey everyone, I'm Unfug11. I'm the developer of the game YouNiverse, a space game inspired by the Bobbyverse books. In this video we are diving into procedural generation to create a spiral galaxy using GoDot's scripting power. By the end you will have a working galaxy generator that you can tweak and expand. Let's jump in and bring our galaxy to life. First, let's create a star node, which will represent individual stars in the galaxy. Add a new scene and set the root node to 2D, rename it to star. Add a sprite 2D node as a child and assign a star texture to it. Attach a new script to the star node and name it star. Set the class name in the script so we can refer it easily. By adding class name star, we make this script globally recognizable. Next, create a new scene. We call it galaxy and set the root node as node2D. We're adding a node star container that eventually hold all the star nodes. Then we'll attach a script to it. This is where all the magic happens. This tells Godot that our script is a tool script, meaning it will update in the editor. Now let's add some variables to control our galaxy. Here's what each variable does. Star count controls the number of stars. Spiral arm defines how many arms our galaxy has. Spiral arm twist adds a curve to the arms. Galaxies aren't perfectly shaped. Spiral arm widths control how spread out the stars are within each arm, adding natural variation. Density determines how tightly stars clustered near the center. A low value spreads stars evenly, while a higher value keeps them concentrated at the core. Galaxy radius determines how big the galaxy is, and galaxy seed makes sure we can generate the same galaxy every time. I'm adding a setter function to every variable, so I can run the ready function every time the value changes. That makes sure that the galaxy regenerates every time the value changes in the editor. I almost forget to add the star node container and the star scene. So we can place them from the editor inside that and have references to the nodes. Before adding new stars, we need to clear out any existing ones to avoid duplicates. The clean container function loops through all child nodes in the star node container, removes them and free ups the memory. This ensures that every time we regenerate the galaxy, we start fresh without leftover stars cluttering the scene. Once we've generated star positions, we need to instantiate each star and add it to the scene. That's what append stars to container does. For each star in our list, we create a new instance of the star scene, set its position and add it as a child of star node container. This makes the star visible in our galaxy. Now add the generate galaxy function and clear the stars array. We use a random number generator and seed it with a fixed number. This means if you input the same seed, you always get the same galaxy. Next we loop through the number of stars we want to generate. In this case we are generating 100 stars by default, but this value is adjustable. Each star is assigned to one of the spiral arms using the modulo operator. If we have 4 arms, stars will be distributed evenly between them. The base angle determines the general direction of each arm. We divide the total circle, tau, which is 2 pi, by the number of arms and assign each star to one of those segments. Now we calculate how far the star is from the center. Instead of placing stars evenly, we use an exponential distribution to make sure more stars appear near the center, mimicking a real galaxy. To give our galaxy its natural spiral shape, we introduce a small twist to each arm. The further from the center, the stronger the twist, creating that beautiful swirl effect. Real galaxies aren't perfectly uniform. To break up the symmetry, we need a random offset, pushing some stars slightly inwards or outwards within the spiral arm. Now we convert our polar coordinates, which are based on an angle and distance, into Cartesian coordinates, x and y, using sine and cosine. Finally, we're creating a star object, assigning it a position, giving it a name like star 0 or star 1, and adding it to our list of generated stars. Now that we have all the building blocks, the ready function brings everything together and ensures our galaxy generates properly when the scene loads. First, we check if star node container is assigned. If not, we exit early and avoid errors. Then we clear out all stars using clean container, generate new star positions with generate galaxy, instantiate and place the stars in the scene with append stars to container. This ensures that every time the scene loads, we get a fresh, properly structured galaxy. I hope you found this tutorial helpful. If you did, don't miss the next episode where I try to optimize all the generation process. Don't forget to like, subscribe and hit the notification bell.